Good evening, children.
Good evening, ma'am.
Good evening. Good evening, children. All right. Only so many responses. Fine. Let's try this question, children. At the foot of a mountain, the elevation of its summit is 45 degrees. After ascending 1000 meters towards the mountain up a slope of 30 degrees inclination, the elevation is found to be 60 degrees. Find the height of the mountain. Try to make the figure, children. Write on the question. Done writing the question, children? Okay. Well, that same question, you can see the answer here. You can see the answer here, children. So say, one second. Yeah. So say this is the mountain. And this is the height, this is the peak of the mountain. So this, when we say height of the mountain, this is the height of the mountain. Mountain. When we say height of the mountain, it is not this height. This is not the height of the mountain, or this is not the height of the mountain. This is the peak of the mountain, the highest point of the mountain. This is the highest point of the mountain, and this is the height of the mountain. This is the height of the mountain, right? Yes or no, children?
Yes, ma'am.
Yeah. So we are not going to show the mountain like this. We're just going to show the height of the mountain using this line segment. So it will be like this, the diagram. At the foot of a mountain, so you can see the diagram is like this, you know, so it's like this. So we take up only this triangle. This is the foot of the mountain. This is the foot of the mountain. All right. And this is the mountain peak. This is the mountain peak. This is the height of the mountain. This is the height of the mountain. And this is the foot of the mountain. This is the line connecting these 2 points, basically. This is the line connecting these 2 points. Foot of the mountain, foot of the mountain, peak, mountain peak, height of the mountain. So we'll be representing only this triangle, this portion. We'll be representing in the diagram, we'll only represent this triangle. Okay, so this is the height of the mountain. And this is the foot of the mountain. As I showed you, this is the line segment connecting this point and the foot of the mountain. All right. At the foot of the mountain, the elevation of its summit is the peak, the highest point of the mountain. At the foot of the mountain, the elevation of its summit is 45 degrees. So this is the summit. This is the peak of the mountain, the summit. Okay, the elevation meaning, so you'll have to join these 2 points from the foot to the summit. The elevation is 45 degrees. So this one is 45 degrees. After ascending 1000 meters towards the mountain up, so you're climbing up the mountain. So from here, when you raise your head and see the elevation is 45. But when you're walking up the mountain, see from here, if you'll have to raise your head and see, the elevation is 45. But the slope of the mountain is not inclined at 45 degrees. The mountain slope is only 30 degrees inclined. The mountain slope has an inclination of only 30 degrees. So you're walking up the mountain now. You're walking up the mountain like this because the inclination is 30 degrees, which is less than 45. It goes like this. You're walking up the mountain slope like this. Okay, the inclination is 30 degrees. The inclination with respect to the ground is 30 degrees. See, this is the slope of the mountain. See, here is not the mountain slope. So this is the inclination, 30 degrees. But when you look up, when you look at the highest point, you're raising your head and seeing. You're raising your head and seeing. I can show you exactly. See here, like something like this. But this inclination is smaller. This inclination is smaller. To look at the top of the mountain, you'll have to raise your head and see. There is no mountain here. The mountain is here like this. But to look at the summit, you'll have to raise your head and see. That is 45 degrees. But this is the mountain. To walk up the mountain, the slope is inclined at an angle of 30 degrees with the ground. All right. So from the foot of the mountain, you raise your head and see the top of the mountain. Elevation is 45 degrees. Now we're climbing up the mountain. The slope is inclined to the ground at an angle of 30 degrees. You're walking up the slope. You're tired. You stop there. And now from here, you look at the top of the mountain or the summit again. The elevation is found to be 60 degrees. From here, you look again at the summit. It's found to be, you'll have to raise your head, still higher. The elevation is 60 degrees. Find the height of the mountain. With this information given, we need to find the height of the mountain. This is the height of the mountain. This is the foot of the mountain. This is the summit. This is the summit. Elevation is 45 degrees. You're walking up a slope of 30 degrees inclination. You stop here. So you should draw the horizontal. And from here, you again look at the summit. You look at the top of the mountain. The elevation is found to be 60 degrees. Now, given this information and the distance after ascending 1000 meters towards the mountain up. So you walk 1000 meters, that is 1 kilometer. You walk 1000 meters, that is 1 kilometer you walk now. And you're tired, so you stop and you again look at the summit. The elevation is 60 degrees. You walk like this, you stop there. So this is the horizontal. And from here, you look at the summit, the elevation is 60 degrees. Now we need to find the height of the mountain. So I've told you that use this triangle to get the height of the mountain. Use this triangle. When you start with this triangle, the calculations are actually easier when you start with this triangle. We have a standard version of the same question. I'll show you that also. There also we will be starting with this triangle. Okay. Now, what is the procedure? So see here. You can see the same figure here, children. You can see the same figure here. So now, look at this triangle. Look at this triangle. Use tan or cot. Use this. Take up this triangle. Use tan or cot. Use anything. Tan or cot. Tan 60 degrees. Opposite by adjacent. Opposite SM. Adjacent PM. Now, keep rewrite SM in different ways. So SM can be written as, what is SM? You started with this triangle. You started with this triangle. Tan 60 is equal to opposite SM by adjacent PM. That's it. If you start like this, you're going to get the answer. Now, SM, we rewrite SM as SO minus MO. SO minus MO. SO minus MO. And down PM. PM. Where is PM? This is PM. This is PM. PM can be replaced with LO. PM can be replaced with LO. That's the second step. Now keep doing this as far as possible. You know, when you as far as possible, keep replacing the line segments. So we started with this. Now we replace SM with SO minus MO and PM with LO. Next, SO is this one. SO is the height of the mountain. So let that remain. Let SO be SO because SO is the height of the mountain which we have to find. Now MO can be replaced with PL. MO can be, because opposite sides are equal. MO is equal to PL. MO is equal to PL. So see here, MO is equal to PL. And the denominator LO. LO is equal to FO minus FL. LO. This one LO is equal to FO minus FL. FO minus FL. So this much we can change. So stop there. Call it 1. Call it 1. Now what you see is the whole triangle is a right triangle, right isosceles triangle. This is 45 degrees. So this side is equal to this side. The whole triangle is a right isosceles triangle. So this, since this is 45 degrees, this also will be 45. So this side is equal to this side. So that means SO is the height of the mountain. FO is also the height of the mountain. Though it is FO, since FO is equal to SO, so you can retain that. You don't have to change. See, why didn't we further change SO? Because that is the height of the mountain which we need to find. FO also we won't change because FO is equal to SO. That's the height of the mountain. Now PL and FL, why we are not changing it further? Because PL, the length of PL can be found using this right triangle. Because we have an angle 30 degrees and we have the hypotenuse 1000 meters. This one can be found. PL can be found using this right triangle, using this right triangle and angle 30 degrees and angle 30 degrees. You can find the length of PL. So we are happy, we are comfortable with PL because we can find the length of PL from this right triangle. We know one angle and one side, the hypotenuse. And FL, same thing. FL also, we can find FL using this triangle. We can find FL using this triangle. See here, this is FL. You can find FL using this triangle. So simple. SO and FO you don't have to replace. That's what you're finding. So let SO be SO. FO can be replaced with SO because they're equal. Now you find PL and FL from the right triangle. Substitute the values and find the height of the mountain. And find the height. So see here, we take up this right triangle. We take up okay. So here I've taken up the whole right triangle. We said it's a right isosceles triangle, right? You can also use tan 45 degrees and show that the side is equal to this side. See here, whole triangle SFO, whole triangle tan 45 degrees is equal to opposite by adjacent. Look at the figure, opposite by adjacent. Tan 45 is equal to opposite by adjacent. 1 is equal to SO by FO. So SO is equal to FO. So this I'm using trigonometry. You show that the two sides are equal. SO is equal to FO. Then find PL from the right triangle. Find FL from the right triangle. And substitute the values in this one. So I've called these results 2, 3 and 4. Substitute the results you get in 2, 3 and 4 in 1. Substituting using 2, 3 and 4 in 1. So use it there. You will be able to find SO. You'll have to rationalize the denominator and you find that the height of the mountain is 1,386 meters. So please start with this triangle. Please start with this right triangle. Yes, children, please work on this. Please work it mindfully. Important question. I'll just get back in 2 minutes, children. Please complete this by then. Done, children? Is it over, children? Is my voice clear?
Yes, ma'am. Yes, ma'am.
All right. Let's see the standard version of the same question. Let's see the standard version of the same question. Yeah. So see this, children. The same question. The angle of elevation of a cliff from a fixed point is theta. So you can see the figure here. The angle of elevation of the cliff, meaning the summit. From the foot of the mountain, you're looking at the summit. The angle of elevation of a cliff from a fixed point is theta. After going up a distance of k meters towards the top of the cliff at an angle of phi. So like you walked up in the earlier question, you walked up the mountain, you walked up a distance of 1000 meters. The inclination was 30 degrees there. Here it is phi. And for obvious reasons, the elevation of the cliff, that is the elevation of the summit. You will have to look high up to look at the summit. That angle will be more than the angle of this, than the angle of the slope on which you're walking. So this phi will definitely be less than theta. Phi is definitely less than theta. 45 degrees, like we saw earlier, 45 degrees. This is 30 degrees. So theta is greater than phi. After going up a distance of k meters, like 1000 meters, here k meters, towards the top of the cliff at an angle of phi, it is found that the elevation is alpha. So see here, I'll use the same numbers which we had in the earlier question. The angle of elevation of a cliff from a fixed point is 45 degrees. 45 degrees, earlier question. After going up a distance of 1000 meters towards the top of the cliff at an angle of 30 degrees, it is found that the elevation is 60 degrees. Show that the height of the cliff is k into cos phi minus sin phi cot alpha by cot theta minus cot alpha meters. I'm not explaining the figure. Same procedure. That's what I wanted to tell you through this. Procedure is the same. Have a look at the figure. You can see the whole angle is theta. This one is phi. K meters. DF is k meters. DF is k meters. And from F, the elevation of the summit is again, elevation of the cliff is alpha. So now when it's a standard question like this, you have to see what ratios are used or what ratios are needed in the result. What are the ratios needed in the result? We need cos phi, sin phi, cot alpha. So for phi, we need cos phi and sin phi. For alpha, we need only cot alpha. And for theta, so there are three angles here. There's one theta, one phi, and then alpha. So there's alpha, there's phi, and theta. For alpha, we need only cot alpha. You can see the final result. We need only cot alpha. For phi, for this phi, we need both sin phi and cos phi. And for theta, it's cot theta. Use these ratios. So what ratio to use? When it's numerical, you use a ratio accordingly. Whatever you want to find, according to that, you use a ratio. So here, what ratios to use? So make use of the result. What is it you have to prove? This one you will have to prove. Use all the ratios used needed to get the final result. So now, as we did earlier, children, work this one first. Work this. Take up this triangle. Take up this triangle. Take up this triangle. And in this triangle, what is the angle we have? Alpha. For alpha, what ratio we have to use? Cot alpha. Cot alpha. So find cot alpha. Find cot alpha. Please first find cot alpha. Why should we find cot alpha? Because we're going to start with this triangle. We're going to start with this triangle. And in this triangle, the angle is alpha. And when you look at the result, alpha is cot alpha here. The T ratio is cot. So cot alpha. So let's find cot alpha. So what is cot alpha? Cot alpha is equal. Oh, I've started with that only here. I didn't notice. I thought I didn't start with that. I'm sorry. That's why I went here. A long time now I prepared this. So I thought I had not worked it. So I started from here. Okay, I've worked it here. Okay. So cot alpha. Start with this triangle. I repeat. Start with this triangle. And the angle is alpha. And we need to find cot alpha. So see here. Cot alpha. What is cot alpha? Adjacent by opposite. Adjacent by opposite. FB by or BF by AB. Okay. Now keep replacing the line segments suitably. So what can you replace BF with? EC. Okay, so write EC or CE. And what about AB? AB can be written as AC minus BC. AC minus BC. You can see here AC minus BC. The numerator BF is CE. BF is CE, opposite sides are equal, and the denominator AB is written as AC minus BC. Now further, CE can be written as DC minus DE. CE can be written as DC minus DE. DC minus DE. And AC we will find later. Now AC is what we have to, AC is the height of the mountain. AC is the height of the mountain. Now, as of now, you cannot replace AC with anything else. In the earlier numerical version, you knew that AC is equal to DC. Here you cannot say that because we don't know the angles. So AC is AC as it is. But BC BC can be replaced with EF. BC can be replaced with EF. So this much we can do. Have a look. Till here. Start with this triangle and have a look till here. So I repeat, so cot alpha adjacent BF by opposite AB. BF can be replaced with EC. So that's what you see here, EC. AB can be written as AC minus BC. Next, CE can be written as DC minus DE. DC minus DE. DC or CD, whatever. And the denominator. CE can be written as CD or DC minus DE, this one. And in the denominator, AC, as of now, we cannot say anything else for AC. So AC is AC, but BC can be written as EF. BC can be written as EF. So this is what we need, this result. This is what we need. This is very important to get the final result. Now we'll try to replace CD, DE, AC, and EF. This is the main result. Now we are going to substitute whatever we find into this and get the final result. So now to proceed, let's find the other ratios. Now for alpha, we've already used cot alpha. For alpha, we already used cot alpha. Now let's use the other ratios. We have to find sin phi. We'll have to find cos phi. And then we'll have to find cot theta. These are the three ratios remaining to be used. These are the three ratios. Cot alpha we found. Cot alpha we already used. Okay. Now these are the remaining ratios. Cos phi, sin phi, cot theta. These we have to still use. So you can find these in any order. I found 2, 3 and 4, right? You can find it in any order. Not that you should work sin phi first and then cos phi, nothing like that. You can work cot theta and then you can work sin phi and then cos phi, any order. Fine, I found sin phi. Sin phi is in this right triangle DEF. In this right triangle DEF. So sin phi is equal to opposite by hypotenuse. So you can see they're opposite EF by hypotenuse K. So upon cross multiplying, you get EF is equal to K sin phi. Now cos phi. Cos phi also we should find from the phi is in this triangle DEF. Phi, this angle phi is in the right triangle DEF. So we have to use the same triangle in triangle DEF. Cos phi is equal to adjacent DE by hypotenuse K. Hypotenuse DF, which is K. K meters, K. So upon cross multiplying, we get DE is equal to K cos phi. So you can see here, see, we got EF, no? EF is here, so we can substitute. This is in this result, we are going to substitute. So see, we got EF. Now EF we can replace here. EF is equal to K sin phi. We got DE. We got DE. DE we can take away DE and write K cos phi. Okay. So we found sin phi, we found cos phi. The only ratio remaining is cot theta. So theta is in which triangle? The whole triangle. The whole triangle we have theta. So in triangle ADC or ACD, cot theta is equal to adjacent by hypotenuse. I'm sorry, adjacent by opposite. Cot theta is equal to adjacent by opposite. So you can see the adjacent side there and opposite side there. Cross multiply, we get CD is equal to AC cot theta. CD is equal to AC cot theta. So see, for EF we found K sin phi, EF. And for DE, K cos phi. And for CD we got AC cot theta. CD we got AC cot theta. Now what about AC? There is AC in the denominator and AC again here we have AC. AC is what we have to find, the height of the mountain or the height of the cliff. See here. Show that the height of the cliff, that is, you should prove that AC is equal to this one. Show that the height of the cliff. What is the height of the cliff? AC. AC is the height of the cliff. But we need to show that the height of the cliff. We need to show that the height of the cliff. Height of the cliff, that's nothing but AC. We should prove that AC is equal to K cos phi minus sin phi, whatever here we have. So AC, we need result. You don't have to replace AC with anything. We have to get the result like AC is equal to. AC is equal to, that is the height of the cliff is equal to. Okay, so we use the results 2, 3 and 4 in 1, in result 1. Using 2, 3, 4 in 1, we get. So one is cot alpha. Cot alpha is equal to, what is CD? CD is AC cot theta. AC cot theta. Then DE is this one. AC, we write AC as it is because that's the height of the cliff. And EF is K sin phi. We substitute all that we found. Whatever we got in 2, 3 and 4, we use it in 1. That's all. Now we just have to cross multiply. We just have to cross multiply. Upon cross multiplying, please have a look. This is what we get. And how to work this ahead? We have to get the answer like AC is equal to. We have to get the answer like AC is equal to. We have AC in 2 terms. We have AC here and here. So we'll have to gather the AC terms on the same side and take out AC common and hence find AC. See, how to work this further, we don't know. So how do we make out? How to work this one further? What to do with this? What is it we have to find? We have to find AC. How many terms contain AC? 2 terms. Gather the terms on the same side. Okay. Take out AC common. Okay. Then find AC. This also is an important question, children. Likely question, standard question in the board exams. Please work this. Take the question. Now the rest of the questions I've prepared for today's class, you are going to work. I'm only going to give the final answer. Let's see how many of you can work it correctly and quickly. There is one construction question in this paper. I want all of you to construct and share your pictures on WhatsApp with me. All of you must construct that and share your pictures on WhatsApp with me. Done writing the question, children?
Yes, ma'am. Yes, ma'am.
All right. Yes, children. Done, children?
Yes, ma'am.
Are you still writing?
Done, ma'am.
So quickly. Okay, let me put it like this. All of you have to take, complete the construction. Complete the construction, and all of you have to take pictures of your classwork and share it on WhatsApp with me today. How many attendees in today's class? 9 or 10? 12. Class, use the emoji, raise your hand. Sudarshan, Balaharish, Dirinesh, Mutwil, Shakti, Manasa, Hariharan, Akshay Ram, Shriya, Srinivasan. Okay, Arna. Okay. All of you completed, finished writing this, children? Please respond.
Yes, ma'am.
Okay. Let's go back to the practice paper. Now, these are simple questions. Tell me the answer for these. You don't have to write the question. Just answer the question. Read and answer the question. You don't have to write it. Just a minute, children. Yes, what's the answer? More than sufficient time. What's the answer?
100 degrees, ma'am.
100.
Yes, ma'am.
Why? What can you say about the? What can you say about? What can you say about PQOR?
It's a quadrilateral.
Okay, something more than that.
Cyclic
All four
quadrilateral.
angles sum is equal to 360 degrees.
Somebody said it's a cyclic quadrilateral, right?
Yes, ma'am.
How will you prove? Supposing you're given this question and asked to prove it's a cyclic quadrilateral, how will you prove it's a cyclic quadrilateral?
Opposite angles are 180 degree.
Which opposite angle? This one and this one, huh?
No, ma'am. ORP and OQP.
Okay, not this one. Then you see. This one and this one, right?
Yes, ma'am.
What is the property? In a
Radius perpendicular tangent.
In a quadrilateral, if one pair of,
Opposite angles are supplementary.
then it is a
Cyclic quadrilateral.
very good, Shakti. Yes. In a quadrilateral, if one pair of opposite angles, in a quadrilateral, if one pair of opposite angles is supplementary, then the quadrilateral is a cyclic quadrilateral. And here this is 90 degrees because radius, tangent perpendicular to each other. See a radius, tangent perpendicular to each other. Opposite angles are supplementary. So PQOR is a cyclic quadrilateral. Is a cyclic quadrilateral. So the other pair is also supplementary because 360 minus 180 is 180. So the other pair also will be supplementary. If this one plus this one is 180, the remaining sum is 180 again. 90, 90, 180 gone. The remaining sum is 180. So the sum of these two angles will always be 180. And this is how we prove it's a cyclic quadrilateral. We need to show that this is, sorry, we need to say that this is 90, this is 90, the sum of one pair of opposite angles is 180 degrees. The sum of one pair of opposite angles is 180 degrees. And so it's a cyclic quadrilateral. Okay, so here since this is 80 degrees, PQ and PR are inclined to each other. PQ and PR are inclined to each other. That is, the angle between them is 80 degrees. The PQ and PR are inclined to each other at an angle of 80 degrees. Find QOR. So this is 100 degrees. All right, good. Answer this question.
Ma'am, 4 centimeters.
How?
Ma'am, as they are given that QPR is 90 degree.
Okay. The
And we
figure,
know,
the figure given does not justify the information in the question. 1 second, children. I'll just put you with another question. I just have to answer something. Children, please try this question. You don't have to, you have all this in your classwork. Just do a rough work and share the answer with me. 1 second. I'll just get back. Yes, why is it? Sorry, we'll go back to the earlier one. So you said, I think Shakti said PQ is 4 centimeters. How?
ma'am, they are given that QPR is 90 degree.
Okay.
And we know that OQP and ORP is 90 degree. As radius is perpendicular tangent.
Okay.
So we will get QR also 90 degree.
Correct. The information, the figure and the information, the figure does not justify the information given. We'll ignore that. Yes, you're right, Shakti. Yes.
And we know that OQ is 4 centimeter and OR is also 4 centimeter, ma'am, as its radius.
Correct.
And we know that PQ is equal to PR.
Okay.
And by that we can find that PQ is also 4 centimeter.
No, not well justified. So you said every angle is 90 degrees. After that, you need to say something else. Because, just because QO is equal to OR, QO is equal to OR 4 centimeters, fine. But why PQ is equal to PR? But why should they be 4? No. You're right, but you need to see, this is 4, fine. These two are equal, correct? These two are equal. But why should it be 4? How will this 4 come here? Yes,
And
class.
we can split it into 2 triangles.
We can prove by congruency.
Something else. Shakti was very close. What do you call a figure in which every angle is a right angle? What do you call a figure in which
Rectangle.
every
Square.
Rectangle.
it's a rectangle.
Rectangle.
How does a rectangle become a square if one pair of
Adjacent
adjacent sides is equal? Correct.
Yes, ma'am.
Now every angle is a right angle. Every angle is a right angle. So the figure in which every angle is a right angle is a rectangle. It can be a square. These are the only two figures where every corner is a right angle. In a rectangle and in a square, Every corner is a right angle. But you can't say it's a square straight away, but you can definitely say it's a rectangle. But when is a rectangle called a square? When one pair of adjacent sides is equal. And here we have adjacent sides OQ is equal, OQ equal to OR. You can also say adjacent sides PQ is equal to PR. So what will you call OQPR? OQPR is a quadrilateral. OQPR is a cyclic quadrilateral. OQPR is a rectangle. Furthermore, it is a square. Yes or no?
Yes, ma'am.
OQPR is a quadrilateral. Yeah, that all of us know. It is a cyclic quadrilateral. Yes, because one pair of opposite angles is supplementary. So it is a cyclic quadrilateral. It is a rectangle because every corner in this quadrilateral is a right angle. So it's a rectangle because we know that this is 90. We know that this is 90. This is given to be 90. So this is also 90. Like this, every corner is a right angle. See, I told you OQPR in this figure does not look like a rectangle. It does not justify the information given, but don't go by the figure. Okay, it's a rectangle. See, it does not look like a rectangle. I don't think I have to tell you more on it again. Going by the angles, every corner is a right angle. So it's a rectangle. And a rectangle is a square when one pair of adjacent sides is equal. So here, this side is equal to this side. Radius. This side is equal to this side, or this pair of adjacent sides is equal. So the rectangle is a square. Now since OQPR is a quadrilateral, it is a cyclic quadrilateral. Because this angle is 90 degrees, not always this figure is a rectangle. Now in this question, the angle, the tangents were inclined to each other at an angle of 80 degrees. So here it is not a square, nor is it a rectangle. In this figure, OQPR is only a cyclic quadrilateral. It's not a rectangle. It is not a rectangle. It's not a square because this angle is 80 degrees. So then this is 100. Here because this angle is 90 degrees, which makes this also 90. OQPR is a rectangle and it is a square because one pair of adjacent sides is equal. So now this is a square. This one is a square. Oh, sorry. Okay, so this one is a square. This is the quadrilateral. This is a square. Doesn't look like a square. In a square, all sides are equal. All sides are equal. So PQ is equal to 4 centimeters. It may be confusing because the figure does not look like a square, children. So like this, it should have been the figure. Radius, tangent, 90 degrees. Radius, tangent, 90 degrees. And the two tangents, the angle between the two tangents is 90 degrees. So this is also 90 degrees. So this is square. This is 4, this is 4. This is square. So this is also 4. The figure should have been like this. It was given like this, so I just had to snip that and put it here. So I think just use this figure to understand. This is the tangent. ORPQ is a rectangle because every corner is a right angle. It's a square because the adjacent sides are equal. So we proved it's a square. That means all the sides are equal and hence PQ is 4 centimeters. Yes, children, this one. We've done all this, so just do a rough work. You don't have to copy the question and all that. Tell me the answer. What's the perimeter of PLM?
$56 centimeters.
Yes, children. What's the perimeter of triangle PLM?
56 centimeter, ma'am.
56 centimeter, ma'am.
You directly use the result or you derive the result first?
Ma'am, derived, ma'am.
Yeah, tell me the derivation quickly.
Ma'am, by perimeter of triangle is PL plus PM plus LN plus LM.
PL plus LN plus NM plus PM. Okay,
Yes,
then
ma'am, we can group PL and LN, ma'am.
very good. No, now
Yes,
itself we can group, no? We should change PL plus what is LN?
LQ, ma'am.
LQ. What is NM?
MT, ma'am.
MT plus PM.
Yes, ma'am.
Yeah, then group. What is PL plus LQ?
It is 28 centimeter.
No, what is PL plus LQ?
PQ, ma'am.
PQ. What is MT plus PM?
PT, ma'am.
PT. Now, what is PQ plus PT? What can you say about PQ and PT?
Both are equal.
Both are equal. So we can say PQ plus PQ because they're tangents from the external point P to the circle. So twice PQ. So in this, you have to derive the result, children. You have to derive the result and then you substitute the values. So we found that perimeter of triangle PLM is twice PQ. So twice 28, which is 56 centimeters. So you'll wonder how we got 4 sides for one triangle. See, PL, perimeter is PL plus LN plus NM plus PM. Very good. You also know it, you might have learned in school. We have also done this in the class here. If you've forgotten and you want to write it down, take a screenshot, children. We need to go to the next one. Okay. Yeah, this is also very often asked, same question, same values. What's the value of X? First, tell me what should we join? You don't have to read the question because you will come across this figure so many times. What should we join?
OP, ma'am.
OP, ma'am.
OP. Yes, Tirunesh. Yes, OP. Then next, Tirunesh.
OQ.
OQ. So, okay. Tirunesh, after joining OP, tell me what will you do?
And then
How
it
do you
will
see?
be a square, ma'am.
Which one is a square?
OSAP, ma'am.
OSAP.
Yes, ma'am.
Okay. What's the measure of this angle? So we have to take up this quadrilateral OSAP. We have to take up this quadrilateral OSAP. This one is given to be 90. How much is this one? This angle? How much is S?
90 degree, ma'am.
90.
Why?
Radius and tangent are perpendicular to each other.
Correct. What about this angle? Why 90? Same reason. Radius, tangent, perpendicular to each other. So what will be the measure of this angle at O?
90 degree, ma'am.
90. So OSAP is a
Square, ma'am.
square. It's a rectangle and then you can say it's a
Rectangle.
square. Yeah, it's a rectangle and then you can say adjacent sides are equal. So it's a square. So everywhere it is 10 centimeters. Everywhere it is 10 centimeters. Now tell me. Now you got this is 10. This is 10. This is 10. This is 10. Yes, children, quickly. You should find the value of X. Yeah, now I'll allow you to think.
Ma'am, X is equal to 21 centimeter.
Okay, you tell me how you got it. Next, what did you find?
Ma'am, I joined O and Q, ma'am.
OQ.
Yes, ma'am.
Okay, then
We know that CR is equal to CQ, so CQ is also 27 centimeter.
CR is equal to CQ. So this is 27 centimeters.
Yes,
Oh,
ma'am.
CQ is 27. Correct. Then
So BQ is equal to 11 centimeter, and they are given BC is equal to 38 centimeter.
where is 13?
38 centimeter. They are
38
given-
you said. Oh, sorry. Yeah, 38. So BQ is equal to 38 minus 27, which is 11. Correct.
Yes, ma'am. So BQ is equal to BP, which is 11 centimeter.
So it's 11.
Yes, ma'am.
So 11 plus 10, 21. That's what
Yes.
I was confused, because why did you ask me to join OQ?
Ma'am, I mistakenly said.
Yeah, no, actually, I had a mind block, because I was like, why we have to join OQ? Yeah, join OP, because then only we'll get 10 everywhere. AP is 10, this is 10. So as Shakti rightly said, this is 27. Class 1 second, children. Yeah, excuse me, children. Yeah. So this is a square. It's a square, so everywhere 10. Then as Shakti said, this is 27. CR is 27. So CQ is 27. CQ is 27. CR is equal to CQ, 27. But the whole thing is 38. So BQ is 11. 38 minus 27, 11. If BQ is 11, BP is 11. Tangents from the same external point B to the circle are equal. So BP is 11. Now we need to find X, which is 11 plus 10, 21 centimeters. Good, Tirunesh. I heard Arnav's voice also, and Shakti. Good. Yes, do the second one, children, or question. Make the cumulative frequency distribution. Make the cumulative frequency distribution. Don't copy the question, just do the answer.
Ma'am, what should we find here?
Given below, it's from the frequency distribution table. It's not from, okay. It's from the frequency distribution table for the above data. Is it okay now?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah. So see, one mistake, one small thing, and makes a big difference. Form the frequency distribution table for the above data. Done, children?
Yes, ma'am.
Yes. Yes, Anna, what are the class intervals?
Ma'am, 0 to 20, 20 to 40, 40 to 60, 60 to 80, and 80 to 100.
Very good. And the frequencies?
0 to 2017.
17 for first CI 17, then second 5, then third 7, fourth 8, and fifth 13.
Very good. Perfect. Zero to 20, 20 to 40, 40 to 60, 60 to 80, 80 to 100 are the class intervals. Frequencies 17, 5, 7, 8, and 13. Good. Yes, solve this equation.
X is equal to minus
Ma'am,
7 and 4.
X is
ma'am.
equal to
X is equal to minus 7 and 4.
plus 4.
X is equal to
Minus 7 and plus 4.
Plus 4.
minus 7 plus 4. What is the quadratic equation we have got?
X square plus 3x minus 28.
Is equal
X
to
square plus 3x minus 28. ma'am.
is equal to 0. Very good. Very good. Yes. So what's the common denominator for x plus 1 and x minus 1?
X square minus 1.
X square minus 1.
Or x simply x plus 1 into x minus 1, which is x square minus 1. Yeah. The common denominator is x plus 1 into x minus 1. The common denominator is x plus 1 into x minus 1. Then we just have to multiply 3 into x minus 1 plus 4 into x plus 1 is equal to 29 divided by 4x minus 1. So cross, this is nothing but x square minus 1. Cross multiply. And on doing that, you get a quadratic equation. What's the equation you said, children? X square
Plus 3x minus 28.
minus 28 is equal to 0. Now this is quadratic. Split the middle term and find the values of x, which are minus 7 and plus 4. X is equal to minus 7.
Ma'am, plus 7. Okay.
Okay. Yeah, this is your next question. Divide 56 into 4 parts in AP such that the ratio of the product of their extremes So the product of means is 5 by 6. And hence find the numbers. How to divide an AP into 4 parts?
Ma'am, is it A minus 3D, comma A minus T, comma A plus T, comma A plus 3D?
Okay, let me write what you just said. If 4 numbers are in AP, how do we assume the 4 numbers?
A plus B, A plus 2D, A plus 3.
Now, when you work like that, here you have to divide the AP itself has only 4 parts. Divide 56 into 4 parts in AP. You have the number 56. Divide that into 4 parts. That's all. The AP doesn't go on forever. The AP does not go on forever. So in such cases, we'll have to make convenient assumptions. The AP does not go on forever, or there are not, the AP does not have many terms. The number is 56. You have to divide 56 into 4 parts so that these 4 parts are in AP. That's all. The number is 56. Now supposing, let me just, what is 10 plus 20 plus 30 plus 40, 70, 100. So supposing I say divide 100 into 4 parts so that they are in AP. Divide 100. I have 100 with me. Divide 100 into 4 parts so that the 4 parts are in AP. So one part is 10, the other part is 20, the other part 30, the other part 40. That's all. This AP has only 4 terms which are in AP. Sorry, this AP has only 4 numbers. And that's all. These are the only 4 numbers in AP. So in such cases, you'll have to make convenient assumptions. When we say convenient assumptions, you'll have to make assumptions so that one of the variables, we have the 2 variables A and D. One of them gets cancelled so that you can find the value of the other one. When you have to find 3 numbers in AP, 4 numbers in AP, 5 numbers in AP, we'll have to assume conveniently. So that of the 2 variables A and D, one of them gets cancelled and you can find the other one. And hence using this one, you can find D and then find the AP. So you must say let the 4 parts. Now I heard from Arnav A minus D, A, correct?
Ma'am, A minus 3D, comma A minus T, comma A plus T, comma A plus 3D.
Yeah, okay. I thought I heard something else. Okay. So let me write, see here, A minus D. See, so just look at your screen. Look at your screen, children. A on the left side, A minus D. On the right side, A plus D. This is what we assume if we have to find only 3 numbers that are in AP. That is, the AP has only 3 terms. That's all. When you have to find an AP which has only 3 terms, then go with this assumption. Let the terms of the AP be A minus D, A and A plus D. Now suppose you'll have to find 4 terms in AP. 4 terms in AP. That is, the AP has only 4 numbers. Then go with this assumption. A minus D, A minus 3D, A plus D. Oh, sorry. Sorry. So I'll write all the numbers so that I can tell you more conveniently, children. A minus D, A minus 2D, A minus 3D, A plus D, A plus 2D. Anyways, you don't need this. Now, when you're taking 3 numbers, go with these 3. Go with A minus D, A plus D. When it is 3 numbers, when it's 4 numbers, go with A minus 3D, A minus D, A plus D, A plus 3D. When it's 5 numbers, go with A minus D, A minus 2D, A plus D, A plus 2D. Here the common difference is D. Here the common difference is 2D. Here the common difference is D. The difference between any two terms is 2D. When to this one, if you add 2D, you will get A minus D. To this, if you add 2D, you will get A plus D. To this, if you add 2D, you will get A plus 3D. The common when you take three numbers like this, the common difference is D. Sorry, children, you're getting distracted. Sorry. Yeah, so I was telling you when you have to find three numbers in AP, go with the assumption A minus D, A plus D. Four numbers in AP, just four numbers in AP, then A minus 3D, A minus D, A plus D, A plus 3D. If you have to find five numbers, then go with the assumption A minus 2D, A minus D, A plus D, A plus 2D. Now here we have to divide. So let the four parts be this one. A minus D, A minus 3D, A minus D, A plus D, and A plus 3D. Now, since we have to divide 56, the sum of the four parts will be 56. The sum of the four parts, A minus 3D plus A minus D plus A plus D plus A plus 3D. The sum of the four parts will be 56. Why the sum of the four parts will be 56? Because you're dividing 56 into four parts. The total is 56. You're dividing 56 into four parts. So the sum of the four parts will be 56. So like this, what happens is minus 3D plus 3D plus D minus D gets cancelled and you're able to find the value of A. 4A is equal to 56. A is equal to 14. Now to find the value of D, there's another information given. The ratio of the product of their extremes to the product of means is 5:6. The extremes are A minus 3D and A plus 3D. Means are A minus D and A plus D. These two are the mean values. Mean A minus D and A plus D. Extremes are these one in the borders. A minus 3D and A plus 3D. So first is the sum of the four parts is equal to 56. When you write this equation, the D is eliminated. Minus 3D plus 3D minus D plus D. So D is eliminated. You're able to find the value of A. Now the other information. Ratio means like this. Product of extremes. A minus 3D into A plus 3D. This is the product of extremes. Product of means A minus D into A plus D. The ratio, see this is the ratio of the product of extremes and product of means is 5/6. The ratio, product of extremes, product of means, the ratio of this one, extremes first in the numerator and then means. That's what is given here. Product of their extremes to product of means is 5/6. And you know the value of D. And you also know the formula A minus B into A plus B is A square minus B square. You know the value of D. So substitute and find the value of A. So once you know A and D, you can find the 4 parts in AP. All right, children. This construction I want you to complete. And so today's classwork, whatever it might be a rough work, it's okay. But the first 2 sums you must have written them neatly. The first 2, that mountain question, one numerical and one standard form. The others okay, rough work is okay. Share your pictures on WhatsApp with me. Please complete this construction also. I'll show you the question. Yeah, this one. Construct a tangent to a circle of radius 2.8 centimeters from a point on the concentric circle of radius 4.2 centimeters and measure the length of the tangent. Write down this question. Okay, so most of you have taken a screenshot. I don't think you're writing. All right, children. So that's it for today's session. Lower your hands and raise your hands again, children. Lower your hands, raise your hands again. Lower your hands first, all of you class, lower your hands. Muthuvel and Hariharan. Lower your hand, Hariharan. Yes, class, now use the emoji, raise your hand. It's immense pleasure, to see all of you at your desk. You've not just connected to the meeting and, gone away somewhere. So nice, children. I'm not reading Hariharan's name. He didn't lower his hand. Shruti, Tirnesh, Balarish, Muktuvel, Shriya, Aksharam, Shakti, Srinivasan, Arnav and Sudarshan. Very nice. Good, children. So please complete this. Take a picture of your classwork and share it on WhatsApp with me today. That's it for today's session, children. Thank you so much. Good night.
Thank you, ma'am.
Thank you.
Thank
It's
you.
too early
Thank
to
you,
say
ma'am.
good night. Yeah, thank you.